Today's topic is IBM Security Guardium Key Life Cycle Management, also known as GLKM. We have today with us Mahesh, and second speaker is Sushant.
Let's see the business challenges organizations face to ensure their data security. Data is growing exponentially due to number of data generating devices like smartphones, tablets, wearable electronics, gadgets with sensors. Over the last 2 years alone, 90% of the data in the world has been generated. Facebook alone generates 4 petabytes of data per day. That's a million gigabytes. With this increasing data, it becomes more challenging to secure it. More we advance in the technology, more tools are available in the market to break the security. For example, quantum computing. For a normal computer, if it takes a trillion years to break a RSA algorithm, then for a quantum computer with 4,000 error-free qubits, it would take few seconds. At the moment, quantum computer with this capacity does not exist, but as technology advances, more powerful machines would evolve. Hence, it becomes a challenge to keep security systems updated as technology advances. Data breach incidents are increasing every year, and hence the cost of data breach. In recent years, it's found that the average cost of a data breach is $4.24 million. Data breaches are not only about financial losses, it's about loss of reputation, loss of customer confidence, loss of brand value, which eventually affects the business. We have more data, and to secure it, we need more encryption keys. Encrypted data is secure if your encryption keys are safe. Also, whenever needed, keys need to be changed, revoked, destroyed, and have them always ready to use whenever needed. So it becomes a challenge to secure and manage this increasing number of keys. Compliance management is a challenging because of changing security landscapes and new regulations, distributed environments across many platforms, multi-country presence, coordination across larger teams, etc. With all these business challenges, when customer is looking for a key management solution, what things comes to customer's mind? Customer need a simple key management solution which has easy administration interface, should be scalable as per requirement, easy handling of key life cycle like creation, distribution, rotation, backup, destruction, etc., and should be highly confidential. All the customers encrypting targets should be supported by the same key management solution. If customer want to protect its tape drives, disks, databases, file systems, cloud storage, data warehouses, or any specific application data, it should be supported from the single key management solution. Solution should be flexible to support all required encryption algorithms. It should be easy to switch encryption types, that too in a cost-effective manner as compared to actual storage investment. Key management solution should be available for deployment on physical servers, on virtual machines, as well as on containers. Also, it should be feasible to migrate the solution from one platform to other. We have seen challenges in data protection, customer requirements. Now let's have a look at the IBM Security Guardium Key Lifecycle Manager features, which helps to secure data with encryption key management. I'll refer IBM Security Guardium Key Lifecycle Manager as GLKM in short for upcoming slides. IBM GLKM simplify, centralize, and automate the management of encryption keys for self-encrypting storage and applications so that we can stay in control of our keys and data. List of supported storages, encryption devices is given in subsequent slides. GLKM supports 3 ways of communication with clients for key management operations on cryptographic objects. It supports IBM proprietary protocol, that is IPP, Key Management Interoperability Protocol, that is KMIP, and third is GLKM REST APIs. With the help of these 3 ways, GLKM communicates with encryption devices and perform various operations on cryptographic objects like generating cryptographic keys, registering cryptographic objects with the server, retrieving objects from the server, or destroying objects on the server. Bring Your Own Key is an encryption key management system that allows enterprises to encrypt their data and retain control and management of their encryption keys. GLKM provides the ability to import keys and use them across integrated applications. Once keys are imported, you have a greater control on them with features such as receiving notifications on expiring, able to replace, delete, and create new keys. Key rotation is the practice of changing access keys on a regular schedule to reduce the likelihood that a key can be abused if it gets compromised. Rotating keys on a regular basis is an industry standard and follows cryptographic best practices. GLKM has a feature as a rollover, which is an automated key rotation process with zero downtime. This feature allows user to schedule key rotation as per need. GLKM provides server certificate management operations like create, modify, delete, import, download, use a chain of trust certificate, export, etc. GLKM's certificate vision dashboard provides deep insight into the health and status of your digital certificates. User can quickly assess the expiration of managed certificates from a central location and drill down by category for greater details. By contextualizing digital certificates, users can better understand their status, risk, expiration dates, and other factors that influence network security. Generating audit logs is a crucial activity for every industry, which records the occurrences of all events, the time at which it occurred, the responsible users or service, and the impacted entity. GLKM provides audit records on distributed systems in common base event format. The audit records are stored in a flat file in the audit log. You can also configure GLKM to generate audit records in syslog format and send them to a syslog server. GLKM can be configured in multiple ways to achieve data redundancy. Active-active configuration, or we call it as multi-master configuration, replication configuration, and backup and restore operations. Multi-master is a cluster of multiple servers that point to a single data source that is configured for DB2 high availability disaster recovery. Multi-master cluster ensures real-time availability of the latest data to all the masters in the cluster. This method is used to achieve consistent and continuous availability of real-time data. Replication is an automated backup and restore mechanism. With this method, you can backup cryptographic objects, configuration files, and other critical information on a master server, and then replicate or restore this backed up data to another server, that is clone server, automatically and on a regular basis. Replication ensures close to real-time data synchronization with continuous key and certificate availability to encrypting devices. Even if the master server is not available, the clone servers can continue to serve the keys and certificates. You can install the master and clone servers in geographically different locations and achieve a disaster recovery solution. Backup and restore is a basic manual method of data replication. Using this method, you can backup your data and other critical information on a GLKM server and then restore the backed up data to create an exact copy of the GLKM server. We are talking about securing the data with encryption keys, but are my encryption keys secure? As soon as we start using GLKM, an AES 256-bit master key is generated by default in the server. The system level master key protects all key materials that are stored in the database. This master key can be stored in 3 different types of master key stores. Java cryptography extension key stores, that is JCE case, this is the default master key store. Hardware security model, that is HSM. To use HSM, we'll have to set it up first by the instructions from the HSM manufacturers. And third is IBM Enterprise Key Management Foundation Web, that is EKMF Web. IBM EKMF Web stores the master key in Integrated Cryptographic Service Facility, that is ICSF. GKLM also allows user to enhance security by creating another master key for each device group, thus providing a two-layered key wrapping. This is a typical flow of key serving for a data encryption using KMIP or IPP, where we can see applications are running on one server and data at rest on self-encrypting storage devices. KMIP and IPP works like a request response protocol, where a key request is sent to GKLM server and in response, key is served for encryption. This is a multiple layers of encryption which GKLM supports. We already have seen this slide, but we'll just go into the deeper of each layer with the examples. The width of each layer represents the coverage that can be achieved from security perspective. The vertical positions of the layers represents the granularity of control and the complexity of implementation and management. Starting from bottom, disk and tape encryption provides coverage for data at rest at the storage infrastructure level. It is all or nothing solution and encrypts data at rest within a storage controller without differentiating type, sensitivity, or importance of data. Therefore, it requires the least organizational effort of all layers with the broadest coverage. It protects against intrusion, tampering, or removal of physical infrastructure. IBM tape drives, IBM DS8000, 5000 family storages, NetApp flash, third-party storages like Bloom-based, Hitachi, Fujitsu, etc. are few examples. If we click on this link, we have another slide just for listing all supported endpoints. Moving up, file or dataset encryption provides coverage for sensitive data by using encryption, which is tightly integrated with the operating system and managed by policies. It is not apparent to applications and it allows for separation of duties within an organization. Security administration can be performed independently of application, database, or storage administration. Examples are IBM Storage Safe, AIX Volume Encryption, VMware vSAN. Moving next is database encryption that provides the capability to protect key database files and database backup images from inappropriate access. Therefore, it is less granular and easier to manage but covers only a certain subset of data. Examples are IBM DB2, Oracle, MongoDB, MySQL, etc. At the top layer, application encryption provides encryption and data protection to each individual application. It is highly granular, specific, and hence complex. Each application will need the necessary encryption capabilities and must be managed individually. At this layer, GKLM protects highly sensitive application data, which is not covered by any of the lower levels. REST-based key servings, KMIP endpoints are a few examples of this top layer. On this slide, we have just listed the supported devices, the storage devices, as well as the non-storage devices. Now let's understand how GKLM works through a use case. In this use case, user wants to store some data on an IBM storage device, that is 3592 tape drive. User first initiates a request to store some data, for example, my information text. Operating system makes a system call and data is sent to tape drive in plain text. 3592 needs to encrypt the data and then store it. Data encryption is done by storage device itself, and key required for encryption is managed by GKLM. To encrypt this data, storage device starts a session with GLKM using a session key and also requests a data key. GLKM does some processing and generates two keys, data key and key encryption key. This data key needs to be shared with 3592 securely. So data key is encrypted using the public key of the key encryption key to generate EEDK. It is also encrypted using the session key that 3592 initiated the session with to generate SEDK. Now these two keys, EEDK and SEDK, are sent to the tape drive. EEDK is written on the header of the tape drive and SEDK is decrypted using the session key to get the data key. This data key is used for encrypting the data, that is my information, and then stores it in the 3592 drive. For read operation, there is a similar flow. 3592 drive sends its EEDK to GLKM and GLKM decrypts it using the corresponding private key to get the data key. And this data key is then used to read data on tape drive. To summarize GLKM benefits, it helps enterprises to secure confidential information. Keys are managed centrally so that those are always available, stored at different place than data to keep them safe. Key management is transparent, means user or the application who are accessing data need not to make any change in their processes even when we add data protection or encryption in place. It's simple and easy to integrate for self-encrypting devices, databases, and applications with GLKM. With GLKM, we can perform cryptographic erasure of data simply by destroying decryption keys. GLKM will also take care of compliances with standards and regulations, which is very crucial and mandatory for smooth operations of every business. That's it for today's session. Thank you.